Okay, now the problem from page 79. Using the cumulative frequency graph, write down the value of the median, the lower quartile, the upper quartile, and the interquartile range. This is a pretty easy one too, and we'll see why in just a second. Now remember, a cumulative frequency graph is a graph which starts from a small number like 0 and goes to a number like a big number like 100 or whatever. In between, it kind of like grows from the small number to the big number. And so, sometimes it looks like an S-shaped curve like this, but not necessarily. So how can we use these graphs? Well, these graphs are useful to see kind of like where the people or the things are distributed among the measurements, kind of like a Box and Whiskers graph. You can see that there are people clustered in certain places by how steep the graph is. Okay, so the way this works is you're like, okay, who like let's say that this is like test scores or something. So it's like who got 10 or less. Okay, so about 4 people. Who got 20 or less? Let's say about 8 people. Who got 60 or less? About 93 people. Okay. Who got 80 or less? Okay, 100 people. Okay. So, and remember that the cumulative frequency here, this isn't percentage. It is the number of people or occurrences. So this is just a coincidence that this one ends at 100, and that's why I said that this one's kind of an easy one, because since it ends at 100, that means it's easier to figure out where's the median, where's the third quartile, where's the upper quartile, where's the lower quartile, because then you just use 25, 50, and 75 to find those numbers. Okay, if you remember, if you have, let's say that you have a graph where the number of people was like 80. How would you find the median for 80? Well, you would divide by 2. Actually, you would take 80, you would add 1, and you would divide by 2. Okay, and then that would be 81 divided by 2 would be like 41 or something like that. Okay, and then so like how do I find the first quartile? I would do 80 plus 1, and then I would multiply times 1/4. Okay, to find the 25th percentile. The first quartile, so that would be like 81 over 4, which is about 20. It's about 20, right? Because it'll be 20.25, round down, it's 20. Okay, and to find the third quartile, we would put 3/4 here instead, and so you can see how that works. Okay, in this case, you can see that we have 100 occurrences or people, so it's trivial. The upper quartile would be at the 75, and the lower quartile would be the 25. Okay, so now we're going to answer the question. So we see how we use the graph. First thing we're going to do is find the median. Well, since the maximum number is 100, the maximum number is 100, that means that the halfway point would be, 101 divided by 2, so that would be, 51. So it would be at, 50, 51, we draw it. And since, graphs are not that exact, so we can't really see the difference between 50 and 51, but it would be about 40. Okay, so you can see that we follow 50 from here to here, okay, from here to here, and then we go down, and then we find the score that corresponds to the 50th or 51st person. The score is 40. Okay, so the median would be 40. What about the lower quartile? How do we find that? Well, we would look at the 25th person, which would be about here. Okay, how do we know it's the 25th person? Well, because we were going to take the total number of people, we're going to add 1, and we're going to multiply times 1/4. And that would be 25.25, so that's about 25. So we take 25, we follow over here, we hit the graph, and we go down, and it's about 32. Okay? Now the upper quartile would be at the 75th person or the 76th person around there. Followed over to the graph, we go down, and it should be about 47. Okay, and then so we have the first three answers. We have this should be 40, the lower quartile should be 32, upper quartile should be 47. Okay, a lot of you might make the mistake of saying, oh, the median is 50, the lower quartile is 25, the upper quartile is 75. Well, the 75th person has the score that is the upper quartile, but whenever they ask for median, lower quartile, and upper quartile, what they're asking for is what is on the x-axis, what's the score, or what's the amount of rain, or whatever. The interquartile range, you have to calculate by taking the upper quartile, which in this case we said it was 47, minus the lower quartile, which in this case we said was 32, and we get 15. So the IQR is 15. Okay, so IQR is the distance between this point here and this point here. So it's like the middle 50% of the people. How spread apart are the middle 50% of the people? And so the IQR gives you an idea of how the whole thing is spread out, because if you know about how spread apart the middle 50% are, you kind of know how spread apart all the people are. Okay, so that was number 7. Now we're going to talk about the problem from page 81. We have a frequency, we have a group frequency table, and we have 200 athletes distributed among all these different weight categories. And you see that like each weight category goes from one number to another, so there's a range of about 5 kilograms for each weight category. So we don't know exactly the weights of these 4 women. We only know that it's somewhere between 45 and less than 50. So each one of these categories works like that. So like for example, in the first one, the question says write down the modal group. Now the modal group is kind of like the mode, but the mode would be like an individual weight, and we don't know individual weights. So instead of asking for a mode, they ask for the modal group. Well, the modal group would be this category here, 60 to 65. So 60 is less than or equal to W is less than 65 is the modal group. And calculate an estimate of the mean and the standard deviation. Well, the reason why they say estimated the mean and the standard deviation is because we don't know the exact weights for each one of the people. And to calculate the real mean, we would need to know that one of these people weighed 46.2 and the other one weighed 48 and the other one, because the mean would be different depending on how people are distributed in this little category. But they're not asking for the exact mean, they're asking for the estimate of the mean. It doesn't mean that you make a guess, it means that you use a specific procedure to find it. And that procedure is take the midpoint of each one of these classes, so like 45 to 50, the midpoint would be, take the difference between these two, which is 5, and then you half it, and it's 2.5, and then you add 2.5 to 45. Or you could look at it as, hey, I'm going to find the point that's exactly the middle between 45 and 50. Some people can do it that in their head. They'll say it's 47.5. If you can't do it in your head, then use your calculator, do it the hard way. 50 minus 45 is 5. And so 50 minus 45 is 5. Oh, it's in scientific notation mode. Let me get out. Change to normal. Get out. 50 minus 45, and the difference is 5. I'm sorry. 50 minus 45. On the emulator, you have to type slow. The difference is 5. And then we want to divide 5 into 2. And that tells us that the distance from the left boundary to the middle is 2.5. So we add 2.5 to 45. And then we get 47.5. So you can see that all these numbers are at the midpoint between these numbers. Okay? And just as an aside, remember that if they have classes or groups that like go from, like let's say they go from, let's say 45 to 49, and the next one is 50 to 54. Now do you see how we don't know what you do with numbers between 49 and 50? So what you do in this case is when you figure out the edges of the classes and you mark them on your graph, you're going to mark on your graph the numbers in between 49 and 50. So instead of marking boundaries like at 49 or 50, you're going to put 49.5. And the next one is going to be 54.5. And those are the boundary for your histogram if you're going to make a histogram. And when you find the midpoints, you also need to find the midpoints of these two. So like the midpoint between 49.5 and 54.5 would be 49.5 plus 2.5. It would be 52, right? Because 52 is halfway in between those 2 points. So that's just like a more difficult problem would be like this, where they don't give you nice boundaries that are right next to each other. Like here, there's 50 is next to 50, so you don't need to think about anything besides the fact that you know, that 50 is between those two groups. All right, so back to the question. So the estimate of the mean and standard deviation, what you would do is you would put all these numbers into your calculator, and the way you do that, of course, is with stat, edit, and then you just start typing them in. So like 47.5. Oops, and you can see it didn't like the way I typed that in because I typed too fast. 47.5. All right, and then the next one is 52.5. And then you keep going, and then of course the other data you would put here in the second column, so you would put the frequencies. 4, 8. Okay, and then once you get all those, which I'm going to do with the thing paused, then we're going to run the one-bar stats. Okay, so I've entered all this data. I've entered all these midpoints for the groups and the frequencies into L1 and L2 lists. I did that with stat edit. Now I'm going to find the estimated mean and standard deviation using one-bar stats. So I put in as the list L1, which would be these numbers here, and L2 would be the frequencies, which I also already entered. And then I go to calculate, and I press enter, and I get the X bar, which is the estimated mean, 63.2. And then I find that the sigma X is 6.62, and I put that down too. So that was the first, or that was B. And now C, they asked to construct a cumulative frequency table and use it to draw the cumulative frequency graph. The cumulative frequency table, you use the border, the boundary weights, which are 50, 55, 60, 65, 70, and you can see that the right boundary and the left boundary are both 50, so you don't need to make any adjustment. Now if it was like this, where the right boundary was 49 and the left boundary is 50, then you would adjust it to be 49.5. But in this case, you would just be 50. So I put the boundaries here, 50, 55, 60, 65, 70, etc. And then at each one of the right boundaries, you're going to mark the cumulative frequency, not the frequency, because it's a cumulative frequency table. And then you're just going to add the numbers up to get the cumulative frequency. So the first cumulative frequency would be the same as the frequency, 4, because there's nothing accumulated before. The second one would be 4 plus 16, 20. The next one would be 4 plus 16 plus 45, 65. Okay, so you would just add up all the ones, like 200 would be all these numbers added together. Or what you could do is you could take the 194, the previous number, and just add 6 to it, and then you get 200. Okay, so we know that there's 200 people total, so that works out, that should work out. Then you put that on the graph, and then you just graph each of those points. So for example, 77.5, well not 70, 80, which is the right boundary, is maps to 200. And for example, 65 maps to 123. So if I take 65, I'm going to go up here, it maps to 123. Okay, so all those blue points are those points graphed. I draw a yellow line through them to show the cumulative frequency graph. And then it says to use it to write down the median, the lower quartile, and the upper quartile. Just like last problem, what we do is we take the middle person, which is 100 out of 200 people, and we draw a line across, and we go down, and that gives me 63. To find the upper quartile, we take the 75th percentile person, or 3/4 of the way to 200. So we multiply 201 times 3/4, and we get 151, and then we just go across, and we go down, and we get 68. And then on the last one, we do that here.